Hi, Meta from MOXA here. In this video, I'm going to show you just how easy it is to configure the MGate 5119 series, a secure, rugged, easy-to-use IEC 61850 gateway specially designed for the needs of power substation applications. Integrating legacy field devices into your IEC 61850 network can be complicated due to all the different protocols involved. Handling and maintaining all these different protocols can be complicated, difficult, and expensive. So we designed our MGate 5119 series gateways to make retrofit installations simple and economical to implement and maintain. Today, I'm going to demonstrate how you can connect a Modbus device to an IEC 61850 network. Here, we have a power meter that's measuring the usage and quality of power being delivered through this power line. And we want to monitor this power meter in a power SCADA. For this demo, we're using an IEC 61850 MMS client simulator to represent our power SCADA. To connect this power meter to our power SCADA, we need to convert Modbus RTU protocol, which this power meter uses, to IEC 61850 protocol, which our power SCADA uses. So we're going to put our MGate 5119 series gateway in between them to handle the protocol conversion for us. And I'm going to show you how you can set this up in just 5 steps. To get started, we'll need to log into the MGate's web console. By default, the IP address is 192.168.127.254, the account is admin, and the password is MOXA. Make sure you change your password to help secure your MGate. On the Network Settings page, assign an IP address and net mask for the MGate, then click Submit to save your changes. If you change the IP address of your MGate, make sure you reconnect to it using the new IP address. On the Serial Settings page, enter the serial parameter settings for your Modbus slave device, such as the baud rate, parity, and which interface to use. Then click Submit. Select the protocol for your device by going to Protocol Settings, then Protocol Conversion. Our power meter uses Modbus, so we'll select Modbus RTU ASCII slave as our protocol. Then we'll click Submit to save our changes. Now, to monitor power data coming from our power meter, we'll need to add the Modbus commands the gateway will be receiving. On the Modbus RTU ASCII master page, go to the Modbus commands section and click Add. Enter the details of the Modbus command you want the gateway to handle. We want to monitor the power frequency, so we're going to enter the Modbus command settings for that, then we'll click OK. After adding all of your Modbus commands, click Submit to save your changes. The MGate acts as an IEC 61850 server. Now normally, you would need to create an SEL file using a third-party tool, but the MGate lets you create an SEL file directly to save time and simplify the configuration process. On the IEC 61850 server page, we're going to select Local SEL File Generator. Click Submit. Then we'll click Create and Edit to access the SEL file settings page. The MGate will automatically load in default settings you can use, and you can change them as needed for settings such as the header ID and IED name. When you're done with the basic settings, click Add to create a logical node. We're monitoring power frequency, so we'll select MMXU for the class and Hertz as the object, then we'll click OK. Here, you can see the MMXU class has been created successfully, and now we can click Submit to create and use the SEL file. Now, we need to create the mappings between our Modbus commands and IEC 61850 objects. Select an IEC 61850 object on the left, and then select the Modbus command on the right you want to map it to. Then click Data Mapping. After we're done defining our data mappings, we'll add the connection details for our IEC 61850 client. Click Submit to save your changes, and we're done. Over in our power SCADA, we can now monitor the frequency data coming from our power meter.
In addition to Modbus, the MGate 5119 series can also convert DNP3, IEC 101, and IEC 104 protocols, so you can easily connect your legacy power devices to your IEC 61850 power SCADA. Thanks for watching, and see you next time.